So I have a lander here around Minmus. What I'm going to try to do with it is land with these landing gears such that I don't have to kill all of my horizontal velocity. Now, I designed it poorly because I put these solar panels on here that I forgot you can't retract. I should have put just the ones that mount flat and put the big ones on the command module. I don't need solar panels this big on the lander, which is kind of foolish. Nevertheless, that's fine. We just have to land much more carefully. I've done this a few times and I've had some success and I've had some catastrophic failures. It's pretty risky to land with a lot of horizontal velocity even with the wheels, because when you bounce you have a tendency to get a lot of spin when you're going that fast. I'm going to burn to lower my periapsis. Careful not to intersect any mountains. That's good enough. Cutting it kind of close there. Can't rely on that to be rendered perfectly accurately from this distance, so we don't want any mountains to catch us off guard. Double check that I'm full of fuel on my lander. Doesn't have a lot of fuel, just barely enough. Very tiny engine. Right, so we're going to angle up radially when we disconnect here, so that when we burn retrograde we don't have a chance of running into it here. And we also want the force of disconnecting it to push the command module up, because it will modify its orbit slightly, ever so slightly. Okay. And the Minmus is rotating this way and from left to right, so this is going to rotate under our orbital path here. Set up a small burn just to drop us in. That's too much because that's going to collide with the mountain, so we're going to do right about here. That's good. And the thing to remember is we're going to do when we do our final burn, it's going to make our descent steeper than what this actually is. So we're not going to land here. We're going to land maybe further back here and have some room to work with here. And we're not going to be landing on this bump because, again, the Minmus is rotating this way, and so it's going to rotate away. That's just because we're in a polar orbit. Ready. So we're going to wait until we get to our next maneuver node. Watching my time here. Let me go ahead and do this while I'm thinking about it. I need to adjust my brake torque. So the red wheels here are the rear ones. I actually have this as a red light pointing this way, illuminating the rear wheels, so the rear wheels appear to be tempted to do my torque a little bit higher than that. We're actually going to completely turn off the torque on the front wheels. Make sure we're controlling from here and not from a command seat, because that can a lot of trouble. My AWS keys, I can pitch up, pitch down, roll left, right, yaw left, right, which is from this orientation as yaw. So I made sure I put my gears on there in such a way that my AWSD keys are intuitive. And that is important because once we touch down, we're going to be, what is going on? Why did that rotate like that just then? Y'all see that? Oh, that's because we're close to the North Pole. That's why. Like, what is going on? Burn full so that we get an estimated burn. That'll be helpful for when we plan our next burn. Right there is good, because our next burn is gonna, let's get rid of that. All right, so we need to kill 160 dV. I could do this until this says 160, but I'm just gonna put in my precise node negative 160. We need a little bit of extra because as we descend, we're going faster and faster. You can see that went up a little bit. Acceleration towards the planet is going to add to the amount of delta V we have to cancel out. So even when we get to here, we're still fighting that gravity acceleration. So it's going to take us, and it won't take us 3 minutes 40 seconds. We don't need to allow that much space, because it will take 3 minutes 40 seconds to kill that delta V, but we won't reach the ground that quickly because we're slowing down, and therefore it will take us longer to reach this point. And the point's actually going to be back here. So some people roughly half that, so that would be a minute and 50 seconds if we halved 3 minutes 40 seconds for our total burn. I'm going to add a bunch to that just to give us some room to work with, because it's better to waste a little bit of fuel than crash into the ground catastrophically. So I'm actually going to allow like 2.5 minutes. So that's going to put us at 6:30 minus 2:30. It's going to put us up at 4 minutes. So I'm going to find the 4-minute spot, which is right here, just pretty close to our node. And the only reason the node, you notice the node thinks that, oh, we're going to immediately descend straight down. That's inaccurate because that assumes we did this burn instantaneously. Because we have that really tiny ant engine, the burn's going to take, 3.5 minutes. So our actual trajectory is going to be more along here, and we'll land somewhere right here, and then we'll roll quite a ways as we're trying to use our brakes to slow us down. Right. So I set up my torque. We made sure that the lander can is the control from here. Let's go ahead and extend our gears. And we'll fast forward to our node. I don't need to start my burn before the node, because I already planned that the node is just there to tell me when I need to start burning. Everything else about the node is pretty inaccurate. I just did it to get this estimated burn time, which you're not going to get if during the current session you haven't fired your engines full throttle. And let's make sure we're perfectly level. Now once we get to the point where our wheels touch down, what we're going to do is there's the little dot at the very top of the nav ball. We're going to line that up perfectly with this dot, and that will ensure that all 4 wheels touch the ground at the same time. Which is, an attempt to minimize our bouncing. I don't need this node anymore because all it did was tell me when I needed to start my burn. And you can see already starting to move back. Now that node, now we're a minute away from landing. So that's the other thing, is because the trajectory gets steeper, even though you're slowing down, it takes you longer to reach this point. The point you're actually getting to is much shorter. So, and one thing I'm going to do is I'm going to focus on killing my vertical velocity. So I switched away from retrograde to stability assist, and now I've angled up a little bit, and that's going to kill more of my vertical velocity, and I'll hang in the air longer so that I have more time to kill my velocity. Not perfectly efficient, but an interesting thing I learned is Kerbals inside a lander, I've always known, do not have a weight. Command seats are very efficient in that they weigh very little, which is why I have all these command seats. I'm actually bringing these guys all here to plant flags and get experience. Sort of a training mission, although I did do a whole bunch of contracts along the way. I sort of let all my Minmus contracts accumulate. Alright, we are 16 seconds. That doesn't seem accurate. That's not taking into account that we're doing a lot more burning here. Right. And the one thing you want to watch is your descent meter here, your rate of descent. You don't want to burn vertical so much that you then get to 0, because then you're staying in the air too long and you're letting gravity. Gravity's going to then pull you down and sort of waste fuel, and then having to cancel more of that. That's the part of the disadvantage of having a really weak engine, is you can't wait to the very last minute to do a strong burn. So you spend more time in the air, which is more time that gravity is pulling you down and accelerating you. Right, I'm going to use my RCS here because this is looking pretty bad. I'm going to make sure I don't use up. Okay, so that's looking pretty good right there. I don't want to use up all our monopropellant. Looking pretty good on fuel. I didn't bring much fuel, but we don't need much for such a small lander with such a small engine. That's the reason for selecting such a tiny engine. Ready. I'm going to switch, because our rate of descent is pretty close to 0. I'm going to switch to... Actually, I'm not going to have much rolling. I've landed as much as 40 meters per second, but that's a pretty crazy landing. Alrighty. Make sure I switch back to stability assist. Turn off my RCS, wasting RCS. Right, kill the engine at the last minute, land. There's a bounce. Turn on the brakes. Dig my rear wheels in. So now I'm pitching back with my reaction wheels to dig my rear wheels in. Careful not to pitch too much that I flip backwards. I'm sort of just kind of popping a wheelie here. The nice thing is, because they're out so far, if I drift left or right as I dig in, it corrected it. You might have noticed right at the beginning. Now the worst thing about this thing is if you try to land much faster than that. I've tried to do some 40 meters per second landings, and it did some pretty violent bounces left and right, and these dipped into the ground and broke off, which is why I say that these were a poor choice. Alright, there we go. If you turn the torque up too much, it'll, even when these back gears dig in, it'll flip forward. It'll look sort of like a horse kind of doing a bronking back and forth. If that is a word. For some reason it's turning left or turning right. I don't know why that is. That's fine. Just don't want it to flip over. That. I think it's because I have an empty seat. Right. I accidentally used up a whole bunch of my monopropellant because I left it on, and as you might know, if you have SAS and RCS on at the same time, it wastes a lot of monopropellant. So there we are. We have landed. And some other little tips for completing missions on Minmus is I was in a polar orbit, so that as I had crew reports to do, I could accelerate time and let the crew report rotate under my orbit, and as I passed over, I could do the crew report. That's a benefit of being in a polar orbit. There is a limit, though. I don't know how close you have to be. Like on Kerbin, I have trouble doing that because I'm too high up to get the option to do the crew report that far above it. You have to pay attention whether the crew report says you have to be above or below a certain altitude. But I didn't, I got down to about 6,000 meters and I had no trouble on Minmus. I had an EVA report to do here, but I didn't want to land on this rough terrain. So in my polar orbit, I dumped this guy out, and he used his EVA to slow down and land at the EVA. And he has just enough left that he's going to be able to fly over to here and get back on the ship, and the ship can take him back into orbit. So hope you found that interesting. It's not the most clever thing in the world, and it does kind of tend to be pretty chaotic, and tends to flip over sometimes if you're going too fast, and it really only works on perfectly smooth ground.